Next, we will move towards law of equipartition energy theorem. So it is very important theorem, and using this law of equipartition energy theorem, you can calculate the ratio of specific heat corresponding to monoatomic, diatomic, etc. And it is very important theorem. It gives the relation between kinetic energy and the thermal energy. It gives the relation between kinetic energy of the gas molecule and the thermal energy of gas molecule. So just I will read the statement here. Law of equipartition of energy states that in thermal equilibrium, the total energy of a gas is equally distributed among all the degrees of freedom, and kinetic energy associated with each molecule per degree of freedom is equal to 1 by 2 kT, where K is Boltzmann constant and T is absolute temperature. So this is the statement of law of equipartition of energy. Okay, what it says, I will discuss in detail. In thermal equilibrium means temperature of the system is constant throughout the system considered. Okay, throughout the system temperature is constant. Then the situation is called thermal equilibrium. Then what happens? The total energy of the gas is equally distributed among all the degrees of freedom. If molecule has 3 degrees of freedom, energy of that molecule will be distributed into 3 different directions. Andre equally distribute agtadantali. If it is having n degrees of freedom, then energy will be distributed into n directions. Okay. Otherwise, among all the degrees of freedom, n parts agi divide agtadantali. So that is one thing. And kinetic energy associated with each molecule per degree of freedom is equal to half kT. Andre 1 degree of freedom ige the energy is equal to half kT irtade. Kinetic energy is equal to half kT. That is the meaning. If it is having 1 degree of freedom, kinetic energy is half kT. If it is having 2 degree of freedom, kinetic energy is 2 into half kT. If it is having 3 degrees of freedom, the total energy is 3 into half kT. And that is how we can understand. If it is having n degrees of freedom, what is the total energy? That is n into half kT. Andre 1 degree of freedom ige half kT amount of energy is observed. That is in accordance with law of equipartition energy theory. And here K is Boltzmann constant and T is the absolute temperature. Okay, and this is called as thermal energy. A half thermal energy anta ಹೇಳ್ತಾರೆ. So basically this kinetic energy is equal to this thermal energy. So it gives the relation between kinetic energy of the gas molecule with the thermal energy of gas molecule. So that is given by this law of equipartition energy theorem. So just to remember, the total energy of gas molecule is equally distributed among all the degrees of freedom. ಅದಕ್ಕೆ n degree of freedom ಇದ್ರೆ energy ಏನಾಗ್ತದೆ n parts ಆಗಿ distribute ಆಗಿರ್ತದೆ. Then second point says that kinetic energy of a molecule per degree of freedom is equal to half kT. ಅಂದ್ರೆ each degree of freedom will carry the energy of half kT. 1 degree of freedom ಇದ್ರೆ ಅದರ energy half kT ಇರ್ತದೆ. Okay, 2 degree of freedom ಇದ್ರೆ 2 into half kT. If it is having n degrees of freedom, the total energy will be n into half kT. So that is the meaning of law of equipartition energy theorem. So what is the application of this law of equipartition energy theorem? So application is application. So basically, okay, let us complete the proof for this law of equipartition energy theorem. So it is very simple. We have to use the simple gas laws and expression for pressure. And in the previous class, in one of the previous class, I have told you pressure of a gas according to the kinetic theory of gases is given by P is equal to 1 by 3 rho into V RMS square, where rho is density of the gas. Already I have discussed this particular expression ಇದನ್ನು ಮುಂದೆ ಬೇಕಾಗ್ತದೆ ಅಂತ ಹೇಳಿದ್ದೆ ನಾನು ಡಿಸ್ಕಸ್ ಮಾಡಬೇಕಾದ್ರೆ. ಇದರ ಡೆರಿವೇಶನ್ ಮಾಡಿಲ್ಲ ನಾವು. We have observed this pressure of the gas equal to 1/3 into rho into V RMS square. What is rho? Rho is the density of the gas. So this density can be expressed as m divided by V, mass divided by volume. Mass per volume gives you density. So it can be rewritten as 1/3 into m into V RMS square divided by capital V. What is m? When m is molecular weight, okay, molecular weight, otherwise total mass of total gas system. V is volume, okay, V is volume of the gas, okay, V is volume of the gas. So this is a density. If you consider 1 mole of the gas, then definitely in 1 mole of the gas there will be Avogadro number of molecules. 1 mole of the gas ಅಲ್ಲಿ ಎಷ್ಟು molecules ಇರ್ತದೆ, there will be Avogadro number of molecules. That we will consider. Here m is molecular weight of the gas. Molecular weight means it contains Avogadro number of molecules. V is the volume of the given gas, and V RMS is root mean square velocity of the gas molecule. And in this expression, capital M is molecular weight, V is volume, then V RMS is the root mean square velocity of the gas molecule. Just remember this expression, P is equal to 1/3 into rho into V RMS square, and that can be rewritten as 1/3 into capital M into V RMS square. Okay. So now rearrange them. Okay, then rearrange matter. Just to take this V to the left hand side volume, you will get P into V is equal to 1/3 into M into V RMS square. Just I have rearranged. I have taken this volume V to the left hand side, so it becomes okay. On the right hand side, you will left with 1/3 into M into V RMS square. Then, according to perfect gas equation, for 1 mole of the ideal gas, if you take the gas is ideal or gas is perfect gas, then we have a simple relation for 1 mole of the ideal gas, PV is equal to RT. Okay. According to kinetic theory, PV is equal to 1/3 into M V RMS square. According to the perfect gas equation, PV is equal to RT. And both are true for 1 mole of the gas. This is 1 mole of the gas because we have taken capital M is equal to molecular weight. Okay. So molecular weight is actually defined as mass of the gas sample which contains 1 mole of the gas. 1 mole is the molecular weight. Okay. So now look at these two expressions. So first expression says PV is equal to 1/3 M into V RMS square. Second equation says PV is equal to RT. So you equate the right hand side. With the right hand side and equate money. What you will get? RT is equal to 1/3 into M into V RMS square. So that expression is it. So the above equation can be rewritten as RT is equal to 1/3 into M into V RMS square. PV idalli ಏನು ಮಾಡಿದೆ ನಾನು? I have substituted RT. PV is equal to RT. So let M be the mass of each molecule. Assume that small m is mass of the each molecule. Na be the Avogadro's number. Okay. So capital M is molecular weight of the gas. What do you mean by molecular weight of the gas? Molecular weight means it is the mass of Avogadro number of molecules. Okay. If small m is the mass of a single molecule, then if you multiply this small m by Avogadro number, that will give you mass of Avogadro number of molecules, and that is nothing but molecular weight. According to the molecular weight of a gas sample or molecular weight of a gas is equal to mass of Avogadro number of molecules. Okay. Andre ಈಗ small m mass of the single molecule. Na is the Avogadro number. So m into Na gives you mass of Avogadro number of molecules. And that is nothing but molecular weight. Therefore, I can write capital M is equal to small m into N into Na, where capital M is molecular weight, small m is mass of a single molecule, NA is Avogadro number. You'll substitute madri idana. In place of capital M, you substitute. So therefore, you will get RT is equal to 1 by 3 into M into NA into VRMS square. So I have substituted for capital M. Capital M badlige ಏನು ಮಾಡಿದೆ ನಾನು? I have substituted small m into NA. Okay, small m into NA. So next part you have to do, you rearrange the terms. You will get, okay, next is multiplying 3 by 2 on both sides. You multiply this equation by 3 by 2. Okay, because we need a half. Half ಬೇಕು ಯಾಕಂದ್ರೆ to prove the equipartition energy theorem, what you have to prove? We have to prove kinetic energy is equal to half kT. Half ಬೇಕು ನಮಗೆ. That's why we have to multiply it by 3 by 2. ಎರಡು ಕಡೆ 3 by 2 ಇಂದ multiply ಮಾಡಿ. So this becomes 3 by 2 RT equal to 1 by 3 into M into NA into V RMS square into 3 by 2. 3 by 2 is multiplied. So 3 gets cancelled here. You left with 3 by 2 RT. You will get 3 by 2 RT is equal to half. 2 ಉಳಿತದೆ, 3 cancel ಆಯಿತು. M into NA into V RMS square you will get. Okay. Now rearrange. ಇದನ್ನು ನಾನು ಈ ಕಡೆ ಬರೆದೆ. So this is written here. The 3 by 2 RT is written here. Then half into this Avogadro number NA is taken to the right side. You will get R by NA. So half M VRMS square is equal to 3 by 2 into R divided by NA into T. What is this R divided by NA? This is nothing but Boltzmann constant. R divided by NA is Boltzmann constant. But R divided by NA is K, which is Boltzmann constant. Therefore, you will get half M V RMS square is equal to 3 by 2 KT. So what I have done? We have taken this NA to the right hand side. You will left with R by NA. R by NA is nothing but Boltzmann constant. K. So we will get half MV square, M VRMS square is equal to 3 by 2 KT. So this is the expression for the kinetic energy if you take the RMS velocity. Okay. So this expression we have obtained. So what you have to prove? We have to prove kinetic energy associated with each degree of freedom is half kT. ಈಗ ನಮಗೆ ಬಂದಿರೋದೇನು 3 by 2 kT ಬಂದು. Just to look at the left hand side is half mu square form. It is kinetic energy form here, but here 3 by 2 kT is obtained on the right hand side. On the left hand side we have half mu RMS square. This is of the form of kinetic energy. Idu kinetic energy formalism. 3 by 2 kT we have obtained. Okay. And next let us see this particular expression. Let U, V and W be the velocities of the gas molecule along X, Y and Z axis respectively. So U is the velocity along X axis, V is the velocity along Y axis, W is the velocity along Z axis. Then RMS velocity is expressed as V RMS square is equal to U square plus V square plus W square. This is the basic expression, because we know that V RMS square, it is root mean square velocity. Okay. For a single molecule, you can resolve the velocity into 3 components. One component along X axis, one component along Y axis, another component along Z axis. Adu ಮೂರು component square ಮಾಡಿ add ಮಾಡಿದ್ರೆ ಏನು ಸಿಗ್ತದೆ? You will get the V RMS square. Okay. So V RMS square is nothing but V average square only. Okay. We have proved that while deriving the expression for V RMS. So this expression is true. V RMS square is equal to U square, where U is the velocity along X axis. So this expression we have V is the velocity along Y axis. 3 by 2 kT W is the velocity along right hand side. On the left hand side we have half M. If you use this RMS square, this is of the for form equilibrium kinetic energy. Idu kinetic energy formalism. The system is in thermal 3 by 2 kT thermal equilibrium idar enaagtade. And next let us see will be this particular expression. Let U, V and W will be the velocities of the gas molecule along X, Y and Z velocity Y axis. So U is the velocity along X axis, Z axis also. V is the velocity along for equilibrium situation or for equilibrium position. The velocity along you will get U square is equal to then V square. RMS velocity is expressed as V RMS square. So these three U square components of velocity will be equal. This is the basic expression. Therefore, what you will get, that you will get V RMS square. V RMS square can be rewritten as root mean you substitute for V square. V square can be equated to U square. For a single molecule. So V RMS square resolve the velocity into three components. Otherwise, it can be one component along x-axis, U square. One component along y-axis. Another component along and therefore z-axis. Similarly, you can get square V RMS square equal to 3V square. V RMS square is equal to 3W square. So V RMS square is nothing but V average square is equal to V square. We have proved that while deriving the expression for V RMS equal. So this expression is true. They are equal. V RMS square equal to is equal to U square. Where otherwise 3V square or 3W. All these V is the velocity along equally y-axis. W is the velocity along. Then you substitute for V RMS square in the previous expression. If you use this, we have for equilibrium position half m. The system is in thermal equilibrium. 3 by 2 thermal equilibrium is that so just substitute for V RMS square will be equally distributed. 3 U square. Okay, so 3 gets the velocity will be equally distributed. M U square H velocity is equal to half k. Velocity this is corresponding to same velocity the x along which gives the average kinetic energy per molecule equilibrium situation or for equilibrium position. You will get U square kinetic energy is equal to B square is equal to half m U square. Okay, what is half so these U square? That is actually kinetic velocity will be equal. Equal for single molecule. Therefore, what you will get because small m is mass of RMS square. Single molecule can be rewritten as so. This is kinetic energy of V square. V square can be equated to U square. X-axis. That is so V RMS square will be U square plus U square along y-axis. What will happen? Otherwise, along y-axis you substitute V RMS U square. Square is equal this is along 3V square. Similarly, you will get therefore half mv square is similarly equal to half you can get u v RMS square equal to 3v square and v RMS square is equal to 3w average square. Kinetic energy per molecule along u square is equal to v square is equal to w. So what you have obtained velocity is equal along x-axis. So kinetic energy is half kt. You can get v along y-axis kinetic energy is half kt. Along z-axis 3v square or 3w half kt. All these says that equally kinetic energy associated with each degree of freedom for V RMS is equal in the previous expression. X-axis half kt iರ್ತದೆ. We have y-axis ಅಲ್ಲಿ half kt ಇರ್ತದೆ. Z-axis ಅಲ್ಲಿ half kt ಇರ್ತದೆ. V RMS is the total energy? Total energy is sum of these. So just substitute for V RMS square. Total energy ಏನಿದೆ 3 by 2 kt. So 3 gets cancelled. Distributed equally m u square. The degree is equal to half equal agi distributed. This is corresponding to each degree of freedom will the x-axis, the energy which gives the average kinetic energy per molecule along x-axis. The average kinetic energy associated with each degree of the kinetic energy is equal to half k. And is equal to this is half m u square. What is each degree of freedom carries? That is actually kinetic energy along x-axis. For this single molecule, the law because small m is mass of the single molecule. Law of equipartition energy. So this is kinetic energy of a so just I will recall what you have done. That is recall half kt. So along y-axis what will happen? Along y-axis andre you pressure expression square is equal to we have started 3v from pressure expression. Similarly, is equal to 1 by 3 rho into square is equal to half kt. Or it can be written as 1 by 3 into m into V RMS square divided by V. Average where m is the molecular weight of a given gas and V is the volume of the given gas. V so what RMS is obtained here root means square along x-axis kinetic energy is half kt. Then along y-axis kinetic energy is half kt. Volume V to the other side also you will get kinetic energy PV is equal to 1 by 3 m into V RMS square. Kinetic energy associated with the ideal gas. Perfect gas equation gives PV is equal to RT. You compare these two expression, right hand side half kt ಇರ್ತದೆ. So you will get z-axis ಅಲ್ಲಿ half kt ಇರ್ತದೆ. What is the total energy? Total energy m into sum of these square. 3 okay 3 by 2 where m is the molecular total energy. Now substitute for this 3 by 2 kt ಇದೆ. ಈ capital M ಗೆ ಏನು ಮಾಡಿದ್ರೆ distributed equally. So you substitute for capital M is equal to small m into Na where so each degree of freedom mass of the single molecule. The energy N is Avogadro number. Okay. If you multiply these two, you will get molecular
average
weight. Substitute
kinetic
here.
energy associated
You will get
with
RT
each
is
degree
equal
of
to 1
freedom
by
is
3 into small m
constant
into n
and
into
is equal to
VRMS square
half
kT. Okay.
For
Then
each degree of
you
freedom
rearrange.
carries
Multiply
the
it by
energy of
3 by
half
2.
kT.
Multiplying
Okay.
3 by 2 on
This
both sides.
proves the law of equipartition energy theorem.
So as to cancel this 3.
Law of
3 is
equipartition
not
energy
necessary
theorem
here.
prove.
ಇದನ್ನು cancel ಮಾಡಬೇಕು.
So just
3
I
by
will
2 ಇಂದ
recall
multiply ಮಾಡಿ.
what
You
you
will
have
get
done.
this expression.
Recall ಮಾಡ್ತೀನಿ.
If you rearrange,
So we have
3 by 2
started
into
from
RT into
the
equal to 1 by
pressure
2
expression
m into NA into
okay.
VRMS.
We have started from
Rearrange
pressure
ಇದನ್ನ
expression
ಆ ಕಡೆ ಈ
P
ಕಡೆ
is
ತಗೊಳ್ರಿ.
equal to 1 by
Then
3
you
rho
will get
into
1 by 2
VRMS square,
VRMS square
or
is equal
it
to
can
3
be
by
rewritten
2
as
into
1 by
R
3 into
divided by
m into VRMS square divided by V,
NA,
where m is the
what is
molecular
R
weight
divided
of
by
the given
NA?
gas,
It is Boltzmann
and
constant.
V is the volume of the
So
given gas.
R divided by
VRMS
NA is
is
Boltzmann constant.
root mean
Therefore,
square
1
velocity
by
of the
m into
gas
VRMS
molecule.
square is equal to
Okay.
3 by 2 kT.
Then
What it
rearrange.
gives, you take the
This gives total
volume
energy
V
of
to the other
single
side.
molecule.
You will get PV is
Idu
equal to
kinetic
1 by
energy
3
of single
m
molecule,
into 1 by 2 into m into VRMS
From
square.
1 mole of
This is
the
kinetic
ideal gas,
energy of
perfect gas equation
single
gives PV
molecule,
is equal to
that
RT
is
equal to 3 by
compare
2
these two expression.
Okay. So
Right
that will have 3 by 2
equal.
kT.
Now
So you'll get,
we have to prove
each degree of freedom
RT
carries
is equal to 1
half
by
kT
3
of
m
energy.
into
So for that what you
VRMS
have to do,
square.
consider
where m is
the
molecular
components
weight.
of velocities.
Now substitute for this
U,
capital
V
M.
and W.
Capital M again madri.
And
You
VRMS square is equal to U
So
square
you
plus
substitute
V
for
square
capital
plus
M is equal
W
to
square,
small m
where
into
U
n
is
is
the
what?
velocity
Small m
along
is
x-axis,
mass of the single
V is the
molecule.
velocity along
N is
y-axis,
Avogadro.
W is the
If you
velocity
multiply
along
these two,
z-axis.
you will get molecular weight.
So for
Substitute here.
equilibrium position,
You
what
will
will
get
happen?
RT is
Thermal
equal to
equilibrium,
1 by
this
3
U
into
square
small
is
m
equal
into
to V
Na
square
into
is equal to
VRMS
W
square.
square.
Okay.
Therefore, substitute here,
Then
you will get
you
VRMS
rearrange.
square is equal to
Multiply it
U
by
square plus
3
U
by
square
2.
plus U square,
Multiplying
or
3 by 2
3U
on both
square.
sides. ಎರಡು ಕಡೆ
Similarly, this
so
VRMS
as to
square
cancel this
can
3.
also be equal to
3 is
3V
not
square,
necessary here.
and
ಇದನ್ನು
VRMS
cancel
square can
ಮಾಡಬೇಕು
also
ಅಂದ್ರೆ
be
3 by
equal
2 ಇಂದ
to
multiply
3W
ಮಾಡಿ.
square.
You will get this
Consider
expression.
1 by 1. Along
If you
x-axis,
rearrange,
you consider.
you will get 3 by 2 into
So substitute
RT
here,
into,
along
equal
x-axis,
to 1 by 2
if you
into m
substitute
into
in the
Na
above
into
equation, 1 by
VRMS.
2 into m into
Rearrange
3U square, you
ಆ
get
ಕಡೆ ಈ ಕಡೆ
equal to 3 by 2
then
kT.
you will get
3
1 by
gets
2 into
cancelled.
m
You will get
VRMS square
1
is
by
equal to
2
3
m
by
U
2
square
into
is
R
equal to half
divided
kT.
by
What is this 1 by 2 m U square? It is
Na
kinetic
into
energy
T.
along
What is R divided by
x-axis,
Na?
because
It
U
is
is
Boltzmann
the
constant.
velocity along
So
x-axis.
R divided
This
by
gives
Na is
you
Boltzmann
the
constant.
average
Therefore,
kinetic
1 by
energy
m
of a
into
single
VRMS square
molecule
is equal
along
to 3 by 2
x-axis,
kT. What it
that
gives?
is equal to half kT.
This gives
Similarly,
total
along
energy of
y-axis and
single
z-axis,
molecule.
they are again half kT.
ಇದು kinetic
Along
energy of
y-axis, it is
single
half
molecule.
kT.
1 by 2
Along
into m
z-axis,
into
it is
VRMS
half
square.
kT. So it
This is
shows
kinetic
that
energy of
the average kinetic
single
energy
molecule
associated
that is
with
equal to
each
3 by
degree
2
of
kT.
freedom is constant.
So that will have
and is
3 by
equal
2
to
kT.
half kT.
Now we have to prove
ಪ್ರತಿಯೊಂದು degree of freedom
each
ಇದು
degree of freedom
the
carries
energy
half
is
kT
half
of
kT.
energy.
So
So for
is
that
the
what you have to do?
proof for
Consider
equipartition
the
energy theorem.
components of velocities
U, V